This is Sivakumar, 12th Standard Business Mathematics and Statistics. Chapter number 1. In chapter number 1, exercise 1.1, you have completed problem numbers 1, 2 and 3. Now problem number 4. Solving the system of equations by rank method. You are given 3 equations with the 3 unknowns x, y and z. Write the equations in matrix form. Five, 3 and 7 x, y, z coefficients 5, 3, 7 the first row, second row 3, 2, 2 26 and 2, and third row 7, 2, 10 7, 2 and 10. Here x, y, z 4, 9, 5 in the right hand side. Consider the first matrix as A, this one capital X, right hand side matrix as B. Now augmented matrix. Two matrices together, A and B. First A matrix 5, 3, 7, 3, 26, 2, 7, 2 and 10. Then followed by the matrix B 4, 9, 5. We have to change this equation into echelon form. For that, you have to consider the first non-zero element. This is the first non-zero element in the first row, below which two numbers are there, 3 and 7, both to be considered, both to be converted into zeros, right? Put equivalent. Write the first row as it is, 5, 3, 7 and 4. First row no change at all. Second row we have 3, there 5, right? With the help of that number only it has to be changed to 0. So that I am multiplying 3 by 5 and 5 by 3, right? Then only can get both 15. That means R2 implies 5 times R2 minus 3 times R1. I do it in rough work. Five R2 means multiply the first row by, second row by 5. 5 3s are 15. Then 5 26 are 130. 5 2s are 10. 5 9s are 45. Multiply odd one by minus 3. Minus 3 into 5, minus 15. Minus 3 into 3, minus 9. Minus 3 into 7, minus 21. Minus 3 into 4, minus 12. Have to subtract. You will be getting 0, 121, minus 11 and 33. Minus 11 and 33. Zero, 121, minus 11 and 33. Now R3, it has to be changed to 0 with the help of that number. Here 5, here 7. So that this number 7 should be multiplied by 5. 5 R3 minus, it should be multiplied by 7. 7 R1. So multiply R3 by 5. 5 7s are 35. 5 2s are 10. 5 10s are 50. 5 5s are 25. Multiply R1 by minus 7. Minus 7 into 5, minus 35. Minus 7 into 3, minus 21. Minus 7 into 7, minus 49. Minus 7 into 4, minus 28. Here 0, minus 11, 1 and minus 3. 0, minus 11, 1, minus 3. Put equivalent matrix 5, 3, 7, 4. First row and second row as it is. Before that, write the first row, no change at all. Look at that second row, look at the elements 121, 11 and 33. Each and every number can be divided by 11. So that R2 implies I'm dividing R2 by 11. Divide 121 by 11 is 11, minus 11 by 11 is minus 1, 33 by 11 is 3. And write R3 as it is 0, minus 11, 1 and minus 3. Again equivalent matrix. Write first row and second row as it is. R1 and R2 no change. Now R3 implies for making this element, because in second row this is the first non-zero number, with the help of that number it has to be changed to 0, so that if you add directly you will be getting 0, correct? 11 minus 11, 0. So that R3 implies R3 plus R2. Without changing the sign you have to put plus symbol. See, R3 plus R2 you can directly add 0 plus 0, 0, minus 11 plus 11, 0, 1 minus 1, 0, minus 3 plus 3, 0. Now it is in echelon form. Now you have tried the rank of AB as well as rank of A. Rank of AB and rank of A. How to find the rank of AB? The entire matrix is AB matrix, correct? How many non-zero rows we can count? This is one non-zero row. It is also non-zero row. Look at here, each and every element is 0 in the last row. So that this is a 0 row. We have to count only non-zero rows. So only 2 non-zero rows. Since 2 non-zero rows. Now, for finding the rank of A, leave of the last column. This is matrix A. This is one non-zero row. Here one non-zero row. It is a 0 row. Here also number of non-zero rows equals 2. That is the rank of A. Same reason. Okay. Since rank of A comma B that is equal to rank of A that is equal to 2, but this is less than number of unknowns. Number of unknowns. We know that number of unknowns x, y and z, 3. Here 2 less than 3. 3, that is number of unknowns. The system. That means the system of equation. The system is consistent and has infinitely many solutions. How to find the solution? To find the solutions. Consider the last equivalent matrix. Write that matrix in equation form. Okay. Here is the last equivalent matrix. First 3 rows and 3 columns, that is an A matrix. 5, 3, 7, 0, 11, minus 1. 5, 3, 7, 0, minus 11, 1. Sorry, 11 and minus 1. This is plus 11 and minus 1. Okay. (11) and minus 1. Next, third row 0, 0, 0. 0, 0, 0. Here as usually x, y, z. Right hand side matrix, we have to consider the last column of that last equivalent matrix, 4, 3, 0. 4, 3, 0. Okay. Now you can multiply 5 into x, 5x. 3 into y, 3y. Plus 7 into z, 7z, that is equal to 4, that is equation number 1. 0x, that is 0, 11 into y, 11y, and minus 1 into z, minus z, that is equal to 3. That is equation number 2. Now last one, 0x, 0y, 0z, that is equal to 0. So all 0 only, no need to write. Here we have 2 equations but 3 unknowns, x, y, z. In that case what to do? We have to consider put z equals k. We are assuming that z equals k in equation number 2 and 1. We first start with equation number 2. In equation number 2, that z has to be replaced by k. What about that k? K, where k belongs to a set of real numbers. Remember, in equation number 2, 11 y write as it is minus that z can be replaced by k, that is equal to 3. Now 11y that is equal to 3, it comes right hand side plus k. Therefore y that is equal to 3 plus k by 11. Okay. Now equation number 1 implies, in equation number 1 here it is 5x as it is plus 3y. That y can be replaced by 3 plus k by 11. Finally 7 z. What is z? K. 7k, that is equal to 4. From that you have to find out the value of x. I am retaining 5x plus 3 into 3 plus k. You can multiply 3 3s are 9 plus 3 into k, 3k. 9 plus 3k by 11 plus 7k, that is equal to 4. I am retaining x alone in the left hand side, others in the right hand side. 4, it comes right hand side minus of 9 plus 3k by 11, it comes right hand side minus 7k. So what is the LCM? 11 is the LCM, you know. 11. Okay, put 1 over here, 1 over here, 1 table for 11, 11 times, 11 fours are 44, 11 table for getting 11, 1 time, multiply, minus 9, minus into 3k, minus 3k. Here 1 table how many times? 11 times, 11 into 7, 11 into minus 7, minus 77k equals 44 minus 9, that is equal to 35. Minus 3k minus 77k, same family, add together, minus 80k divided by 11, that is a value of 5x. So 5x, that is equal to, since 5x is there, 35 and 80, which one is common? You can take 5 as common. 7 minus 16k divided by 11. Both 5 get cancelled. Now we can write x that is equal to 7 minus 16k divided by 11. Now we got the value of x also. Finally write the solution. Solution, x comma y comma z, that is equal to x that is equal to 17 minus 16k by 11 and y that is equal to, here it is 3 plus k by 11, 3 plus k by 11, and we considered z as k. Already I told you where k belongs to R. We know what do you mean by R? R is a set of all real numbers. Uncountable numbers are there, so that it has infinite number of solutions. We can verify by considering any one value. Verification. Okay. I consider k as 0. 0 belongs to real number. No. When k that is equal to 0, what about that x, y, z? I am going to replace k by 0 over here. If you replace k by 0, you will be getting 16 into 0, 0 only. So only 7 by 11. If you replace k by 0, you will be getting 3 by 11. If you replace k by 0, you will be getting 0 only. Right? This is x value, y value and z value. Now consider any one of the given equation. You have to verify LHS and RHS are equal. Here we have 3 equations. I consider the first equation, 5x plus 3y plus 7z. 5x plus 3y plus 7z. Listen carefully. 5, x can be replaced by 7 by 11. This is 11 plus 3 into y can be replaced by 3 by 11 and 7 into z can be replaced by 0. 5 7s are 35 by 11. 3 3s are 9 by 11. That is equal to, what is the common denominator? 11. Add the numerator, 35 plus 9, that is equal to 44. 44 by 11, that is equal to 4. And look at the RHS of equation number 1. Here it is. That is equal to 4. Now LHS and RHS are equal. That's all. Problem number 4 is over. I'll be continuing problem number 5 in the next video. Thank you, children.